Okay, today we're going to look at 1.1a, or the first part of fractions. We're going to look at reducing fractions, multiplying fractions, and dividing fractions today. So first, let's look at reducing fractions. When you reduce a fraction, you want it to be in simplest form. So you want it to not have any multiples in common. So you want to divide the top and the bottom by the same number. So when you look at this first example, 10/15, if you know what number goes into the top and the bottom, then you don't have to worry about it. You can just divide both of them by that number. But if you don't know what factor they have in common, you can do what's called factoring it. And really the easiest thing is to go to the smallest number. So out of 10 and 15, 10 is the smallest number. And what you do is want to start to see what would divide into 10. Well, 1 will always divide into 10, so the next multiple to start with is always 2, and you think, okay, 2 would go into 10 5 times. So 10 factors to be 2 times 5. Then you can look at the bottom, and because you can say, well, will 2 go into 15? No, but 5 will go into 15, so you know that 5 is the one that divides into both of them. So you could go ahead and factor 15 to be 3 times 5. And then what you're doing is canceling out the one they have in common. And so what we're left with is a 2 on the top and a 3 on the bottom, because you're dividing by this, or you're canceling out the factor they have in common. Now, another way to do it is to think about that 10/15, go to the smaller number 10 and think, okay, what multiplies to be 10? 2 and 5. You look at the bottom and say, will 2 divide into 15 evenly? No, because it would give a decimal, but 5 will divide. So in that way, you can just divide them both by 5 and be left with 2/3. So you can either factor it and cancel those factors, or you can just think what number would divide into the top and the bottom in order to simplify it. So let's look at 24/26. So this is a much harder one to look at because there's lots of numbers that would divide into it. 2 would go into it, 4 would go into it, 6 would go into it, a lot of numbers would go into it. You want the biggest number that would divide into both of them. So the way you can do that is go to your smaller number, which is this 24. I mean smaller between 24 and 36. So whether it's on the top or the bottom, go to the smaller number and divide it by 2. Do you see 12 would break up to be 24 would break up to be 2 times 12, because 2 goes into 24 12 times. What that does is give you the biggest factor. And so you look at that number 12, and if 12 will go into 36, 12 will 3 times, then you can really just divide both of those by 12. You have to divide the top and the bottom by the same number, leaving you 2/3. So that's kind of the quickest way to do it. Another way to do the same problem is just factor the top factors to be 2 times 12, the bottom factors to be 3 times 12, the 12s factor out, leaving you 2/3. Now, one mistake a lot of people make on this one, so let me just rewrite the same problem again, is they don't pick the biggest number. Let's say you look at this and go, oh, 6 will go into both of those. Well, it will. So 24 divided by 6 is 4, and 36 divided by 6 is 6. So that's a correct answer, but it's not in simplest form. So if you don't pick the biggest number, like here, I'm sorry, that camera's shaking. Here I divided it by 6. I'm still not in simplest form because I can still divide them by 2, which leaves me that 2/3. So any of those ways are fine to work it. Just pick which way makes more sense to you. Just always check before you finish that it's in simplest form, that there's not another number that would go into both of those. Okay, so that's reducing fractions. Then let's go to multiplying fractions. The problem with fractions, I think, is that each type, multiply, divide, add, subtract, all have different rules that you have to follow. So it's about learning those rules. So when you multiply fractions, the rule is you want to cross cancel and then multiply the top and the bottom. So what I mean by that is, well, first of all, think about multiplying. Multiplying, you can use the symbol dot means multiply, the symbol X means multiply, and also parentheses, but we won't be looking at those. But when you think about multiplication, think about this X that we learned in elementary school, because that's going to give us the symbol for cross canceling. When you see this dot, it can also be in X, and that's going to make me think I want to look on the diagonal and cross cancel. So what I mean is you want to look this way to 2/9 and see if there's any number that will divide into 2 and 9. And there's not. 1 would, but again, 1 doesn't count because 1 goes into everything. So we're just looking for 2, 3, 4, 5, and so on. So nothing will cancel that way. So then we look on this diagonal. Will 5 go into 7? No, there's nothing there. So for this one, we can't cross cancel. So we're just going to multiply across the top and across the bottom. So 5 times 2 is 10. 9 times 7 is 63. And that's our answer. You do always want to check to see if there's a common, if you can reduce it. But if you can't cross cancel, then you can't reduce it in the end. So that's just our answer. But let's look at this next one. So when we look on the diagonal here, again, we're thinking about this dot means multiplication. So we're looking on the diagonal. So when you look on this diagonal this way, if you'll get in the habit of always going to the smallest number, whether you're reducing or anything like that, go to the smallest number, 7, because 7 is smaller than 21, and ask yourself, will 7 divide into 21? In other words, 21 divided by 7 is 3. So what you're going to do is you're going to divide both of these by 7 because that's what you can reduce it by. So on this top, 21 divided by 7 is 3. And on the bottom, 7 divided by 7 is 1. We cross-canceled on that diagonal. Then we're going to look at the other diagonal, 4 and 8. Go to the smaller number. Will 4 divide into 8 evenly? Yes. So we're going to divide both of these by 4. So 4 divided by 4 is 1. 8 divided by 4 is 2. So we cross-canceled. And now we're going to multiply across the top and the bottom. So 3 times 1 is 3. 2 times 1 is 2. And that's our answer. I should have boxed those. Okay, now that is considered an improper fraction. You could change that to be 1 1/2. But in algebra, when we go to simplify radicals in chapter 6, we never work with mixed algebraic fractions. So we're going to just leave everything as an improper fraction and not worry about changing it. So if you write 1 1/2 for that answer, it's perfectly okay. But you'll see me just leave it as 3/2 and not worry about transferring it. Okay, this next one though is a whole number times a fraction. So anytime you have a whole number, you can make it a fraction by just putting it over 1. So the first thing we're going to do is make that 36 over 1. Then we're multiplying, so we're looking at that cross-canceling. Well, when you have a 1, that means that's already in simplest form. So I'm just going to leave the 1 and the 4. That's just going to stay like it is. But we're going to look at this diagonal and simplify. So you go to the smaller number, 9. Will 9 divide evenly into 36? Yes, it's 9 times 4 is 36. So we're going to divide the bottom by 9 and the top by 9. So 36 divided by 9 is 4. 9 divided by 9 is 1. So we cross cancel. Then we multiply across the top and the bottom. 4 times 4 is 16. 1 times 1 is 1. And you can leave it like that, 16 over 1, or most people will change that to a whole number of 16. So either way is correct. I usually go ahead and simplify that one just because it's easy to see that it should be a regular 16. Again, on this one, if you put 1 1/2, perfectly okay. I would never count it wrong. You just don't have to go that extra step if you don't want to. Okay, so when you're multiplying fractions, you cross cancel if you can, and then you multiply across the top and the bottom. And think about that dot, meaning multiplication, also is an X. And I don't know, you'll see I'm a very visual teacher, so I think of that X as telling me to look on the diagonals. Okay, next we have dividing fractions, and you see this symbol. Sorry, I'm shaking the table. I'm trying really hard not to do that. This symbol for division actually is going to mean flip. So when we divide fractions, we're going to flip the second fraction, and then we're going to multiply. So then we're going to use the rules we learned before. But before we can multiply, we've got to flip the second fraction. So again, visually, if you look at this, the first fraction is always going to stay the same. We're going to change it to multiplication and kind of think of division. I don't know, if I had to make an emoji for flip, that would be a good one showing that you want to flip that over. So this division sign is going to tell us to flip the 3/10 and make it a 10/3. So for division, you leave the first fraction like it is, you change it to multiplication, flip the second fraction, and now remember, multiplication means to cross cancel. So we look on the diagonal. Will 3 divide into 7? No, because it would leave a decimal. So 7 and 3 stay where they are. But when we look on this diagonal, will 5 divide into 10? Yes. So we're going to divide them both by 5. So 5 divided by 5 is 1. 10 divided by 5 is 2. And then we're going to multiply across the top and across the bottom. So 7 times 2 is 14. 1 times 3 is 3. And again, that's an improper fraction, but we're just going to leave it like it is. Okay, this next one, again, on the test, these will be all mixed up. So that's why this symbol is so important. Think of this division as meaning flip and multiply. So we're going to leave the first fraction like it is. We're going to change it to multiplication, flip the second fraction. Now, multiplication means to look on the diagonals and cross cancel. I'm sorry, this is shaking, and so let's look on this diagonal. Will 7 divide into 21? Yes, so we're going to divide them both by 7. So that leaves a 1 on the bottom and a 3 on the top, because 21 divided by 7 is 3. Then we're going to look on this diagonal. Will 6 go into 24? Yes, so we're going to divide both of these by 6. So 24 divided by 6 is 4. 6 divided by 6 is 1. And then we're going to multiply across the top and across the bottom. 4 times 3 is 12. 1 times 1 is 1. And 12 over 1 is the same as just 12. Again, either way you leave that answer is perfectly okay. Okay, this last one is really one of the most missed problems when we work these in class, and that's because you try to flip things before you change it into a fraction. But 30 is not a fraction, so we're going to make it a fraction by putting it over 1. So first we have to do that. Then it's division, so we're going to leave the first fraction like it is. We're going to change it to multiplication and flip the second fraction. Now, multiplication means to look on those diagonals. 1/5 won't change at all. Those are already in simplest form, so 1 and 5 aren't going to change. But 2 will divide into 30, so we're going to divide both of these by 2. So 2 divided by 2 is 1. 30 divided by 2 is 15. And then we're going to multiply across the top and the bottom. So 1 times 1 is 1. And then 5 times 15 is 75, I think. Yeah, that's right. And so that's our answer. So that's reducing, multiplying, and dividing fractions. So you're now ready to work the practice problems in 1.1a, and they should be uploaded on the on Blackboard right next to this. And so just remember, on these, I give you the problem and the answer, but you can't get this answer here without showing these steps. So on your test, you can't just have this problem and this answer. Whatever steps I show on the videos, you have to show the same steps on your test and on your take-home quizzes. You've got to show all your work to receive full credit on any of the take-home quizzes. And the same thing on this one. If this problem was on your take-home quiz, you've got to show me how you changed it to multiplication, you cross-canceled, and then you have your answer. You must always show all your work on every problem that we do on the take-home quizzes in the